Hi everyone, I'm going to go through the first two guided problems. So we're looking at this problem here. The length of it is 9 meters, the height of it is 7 meters, and the width of it is 2 meters. So what I'm going to do with this problem, it's very important that you do this, is you approach the problem systematically. You're organized in your problem solving process. So this shape right here looks a little bit like this. So the way that I do these, I know that I need to solve for the front and the back, this pair here, and then the sides, that pair, and then the top and the bottom, that pair. It doesn't matter which pair I solve for first, but I'm going to need to do all of them. So let's go ahead and model. I'm going to model the problem like this. Front and back. And then we'll also solve for the two sides. And then finally we'll solve for the top and bottom, which are also the bases. Okay, so we'll do the front and the back, which is, once again, thank you to Luis Ruiz and Marcelo for making this. Let's see. Something like this, the front and the back. So I know that the length here is 9. So I'm going to make it easy for you guys to see. This is what we're solving for here, the front. That's what we're solving for. Well, this rectangle, I'm not giving this length, but I'm giving this length. And it's the same thing, you just pull it straight across. So this is going to be 9 times, this length here is 7, and that's going to be equal to 63. And I'm going to multiply it by 2. And why am I going to multiply it by 2? Well, because there's the front, and there's also the back here. So I think it looks a little, it can come out a little bit, the pink and the orange here. It's the same thing. This front is the same thing as the back. Okay, so times 2 will give me 126 meters squared. Okay, now the two sides, what I'm solving for is this part right here, this rectangle, and this rectangle. So I know that this one, it's 7 meters long. You just can stretch it across. Well, I guess we could just solve for this one here. 7 meters by 2 meters. So we're going to do 7 times 2, which gives me 14. I'm going to multiply by 2. Well, there's two sides. That gives me 28 meters squared. And now the top and bottom are the bases. We're going to be solving for this one right here. And this one right here. Those two, and they're the same. So the bottom here, the top, we're given the coordinates here. The width is 2. And the length is 9, so it's going to be 2 times 9, and that is equal to 18. Now multiply by 2. Why are we multiplying by 2? Because there's two sides. 36 meters squared. And now the last thing I need to do is I just need to add all these areas, these pairs up. So 126 plus 28 plus 36. It's still on the screen there. 6 plus 8 plus 6, that's 12, and that's 20. 0, 2, 2, 4, 6, and 9, and 1. 190 meters squared. We'll put it in the box here. 190 meters squared. Okay, let's go on to problem 2. 2G. Solve for the total surface area below. Okay, total surface area. Okay, and it gives us 845. This is 8 meters, this is 4 meters, and this is 5 meters. So I'm going to model it the same way. Stay organized in this problem-solving process. So I'll do the front and the back. I'll do the two sides. And then finally, right here, I'll do the top and bottom, which is the also known as the two bases. Now, that's kind of weird. Mr. Corbett, there's two bases? Well, in prisms, yes. There's always two bases. This is one good example of maybe taking notes on something that I'm not writing down. Remember, I'm trying to get you guys to, at the end of the year, say, Mr. Corbett, I don't need you. I can learn math on my own. There's two bases. In a prism, it's the two equal parts. So here are the two equal sides. The triangles are the bases. They're technically the bases. I know it can rest on this rectangle, but there's two bases in any prism. Here it's these two triangles. And here I'm arbitrarily saying that it's going to be these two. But we are in total surface area, so we are going to solve for the whole thing. Okay, front and back. So first, we're solving for this one. I should have done this the first time I taught this. I don't know why I didn't do squiggly lines. And this one. The front and the back one. So the front one, it's going to be 5y times, and how tall is it? Well, it doesn't give me either of those, but it gives me this one here, and so I can just drag this here, and it's 8. So 5 times 8 is equal to 40. Don't forget, I need to times 2. Why? Well, because there are two equal sides. So that's going to be equal to 80 meters squared. Two sides. Now let's see. So the two sides, we're going to do this one and this one here. Well, this one right here, it's 4y. It's going to be 8 tall. So it's going to be 4 times 8. 4 times 8 is equal to 32. I'm going to multiply by 2 because there are two sides. So that's 64 meters squared. Now, the top and the bottom, so I'm going to be solving for this one and this one. You can do a better job with the squigglies than I can. The bottom is 5 by 4. 5 by 4, and that's equal to 20. And then I'm going to multiply by 2, which is equal to 40 meters squared. My last step is I just need to add all these up together. Plus 64 plus 40. What did I do? Yeah, 184. So my total surface area is 184 meters squared. All right, everybody. So takeaways from this. You have one problem to do. I'm giving you one problem. Please do that problem. And also, please submit your answer at the end of this video on a puzzle. I'm not grading it, relax, but I want you to put it in because it lets me know as your teacher who I need to help. So, repeat, this problem Student practice problem. Student practice problem. Please make sure that you put your answer of the student practice problem into Edpuzzle. About half of you, or not half of you, but a quarter of you in each class are still not submitting your answers. It is making it a little bit more difficult for me as your teacher. So please do it. It's not graded. Thank you very much, everybody, and happy doing math.